Alright, Algebra 2 guys, we're in Module 1, Unit 3, Lesson 2. We're going to multiply the rational expressions. We just learned how to simplify them. Multiplying is just basically an extra step, so you'll see what happens here. Alright, in our opening exercise here, I want you to create a visual representation here of basically go back to 4th grade, 2/3 times 4/5. And I basically have 4/5 here. I want you to find out what 2/3 of that would be in terms of squares and figure it out. So pause the video, take a shot at it. So I'm hoping you basically took this 4/5 and you need 2/3. You got to break this thing into 3 equal parts. So I'm going to draw a line and another line through it. And of course 2/3 of it would be shading in 2 sections. So I'll shade in all the 2 sections right here. So we did 2 out of the 3 bars. So you take a look at it, what did you end up with? Well, I have a grand total of how many things? Well, I've got 1, 2, 3, 4, 5 on the top row by 3, so that's 15 squares total. And I shaded in on both parts. You got to have the blue shade that originally the 4/5 and the other one says I got 8 out of 15. So think about it. How did you do that way back when? We basically just we multiplied the numerators, so 2 times 4 is 8, and the denominators, which is 3 times 5 is 15. And if you had to reduce, you would reduce, but that is our answer. So as you can see, if A, B, C, and D are integers here like they're talking about, and the bottom 2, C and D, cannot be equal to 0 right here. It's real easy. Multiply the tops, multiply the bottoms, and then reduce wherever possible. So let's take a look at an example down here. Use this conjecture to go with this thing. It's got x cubed over 4y and y squared times y squared over x. All you have to do really is take a little piece of this. So if I go into this x down here, that's 1x. It cancels with one of these, so that knocks that down to a 2. By the same thing, I've got 2 y's here, 1 y in the bottom, so the 1 y cancels. We'll get rid of the exponent here, where it's really an unwritten 1 now, and just put the whole thing together. So what's left in the top? I have an x squared in the top. I have a y left in the top. In the bottom, I just have a 4. I cannot reduce any more than that, and that's your answer. So let's take a look at example 2. So now, welcome to Algebra 2. We basically are going to take a look at this baby. We've got a binomial over binomial times another binomial over another binomial. Remember, you can't just reduce things like these x's and stuff, or whatever numbers go into whatever, because of the plus signs here, unless it's identical in parentheses, and the entire parentheses can get removed. And it's got to be all multiplication. So what comes into play? Yes, you got it. We've got to factor. So if I take a look at the top part here, 3x minus 6, obviously they share a 3, so I pull out a 3, I am left with x minus 2. In the bottom, what do they share? Another GCF there, they share a 2, so I am left with x plus 3. In itself, there is absolutely nothing I could reduce here. The parentheses don't cancel or anything. If I move on to the other side, same time situation, they share a 5, so I get 5 times x plus 3. And in the bottom, I share a 4 when I'm left with x plus 2 when I pull it out and I factor it out. So now is where you have the fun. Here's the nice thing. You are allowed to reduce up and down. Anything straight up and down on a fraction, just like we did when we simplified. But you can also reduce crosswise. I'm talking about diagonally. You cannot do horizontal cancellations, okay? It doesn't work that way. Up and down or on a crisscross type thing, you can cancel. So let's see what cancels here. Obviously, the x plus 3's cancel. The x minus 2's cancel, okay? And do I have any other numbers? No, the 3 in the top there does not cancel with either the 2 or the 4, nor does the 5. So when all is said and done, multiply these top 2 back. So 3 times 5 gives me 15. And in the bottom, I got a 2 times 4 is 8. And you are fine to leave it as an improper fraction. I can't reduce anymore. Good answer, okay? If they ask you, where was it undefined? Well, now you got to go back and take a look at it again. Where was it undefined? Back here, if you take a look, x cannot equal negative 3 because of this one right here. And on the other one, x can never equal what? A negative 2. That would make these problems undefined in the bottom. All right? Just so you're aware in case they ask you that type of question. All right, move on to example 3. All right, with example 3, I suggest maybe you try pausing the video. I've got the one binomial over a trinomial. I got another binomial over a monomial. And I think you know how to factor this stuff, and so you can start canceling it. So pause the video, give it a shot yourself for a second, and then I'm going to come and talk to you how to do it. Okay, welcome back here. If I take a look at the top there, that's a pretty easy one. I know I can pull out a 2 out of the x plus 6. I will be left with x plus 3. Obviously, the bottom on the other side, I can't factor all. The 2x goes there. If you're stumped on the other one, start playing with things and see what's going on here. Obviously, if I have an x plus 3 in the top, there's a darn good chance there's got to be in the bottom. Well, since it can't be in the bottom there, I'm willing to bet some money. There's probably an x plus 3 right there. And I would almost give it a willing shot to put that down, that one of the factors is probably an x plus 3. So if I take a look at this trinomial right here, x squared, we know it's x and x, so I should put an x and an x. And then we'll go from there. So I'll put an x and an x. We got a plus sign here, so we put the plus sign always down. And then the second one here, let's see here, we got a 6. The boss here says it's got to be the opposite, so my bad on something like that. I'll take my eraser here, I'm going to erase this plus right here, and I'll make that a minus then instead. First, I'm reversing the order only because of the way I did it. And we need what factors of 6, subtract the 1, so it's 2 and 3. And if I go and check it out, that is a good case. Now, I would also use the clue for that. I have to actually factor the top here. And if you forget the fact that that's dots and the difference of perfect squares, use the factor you got right there, 2x minus 2. So there's a good chance that's an x minus 2 there, which might give you a clue. Oh yeah, x squared is x and x. And how do I get 4? 2 and 2, and one's plus and one's minus. And we get it all factored out. Now that everything's factored out, all my plus and minus signs are inside parentheses. Everything's being multiplied across the top and across the bottom. So now we can cancel stuff. So x minus 2 cancels with x minus 2. X plus 3 cancels with x plus 3. The 2's right here cancel. Okay? And we're pretty much wiped out. This is all I've got left. So my answer is the x plus 2 on top. And the only thing left in the bottom is an x. So that's my answer there. And don't you dare try canceling these x's. You can't do that. Once again, this one is attached to a plus sign. So unless I put it in parentheses and it's identical in the bottom, which it won't be, can't cancel it. So let's move on to our last example. All right, my friends, we've got another one here. And this one's going to be a little more chaotic. If you can see, I got an exponent of negative 2 here, and that's going to drive us a little bit crazy here. These two, you can basically see some GCFs going on. These two are trinomials, but that negative 2 we need to address. And we got to think back to way back to 9th grade here and how we dealt with that. Okay. So, the negative exponent. First of all, we got to take care of that. If you remember, a negative exponent means we got to flip this thing. So, the first thing I'm going to do here is put the 3m plus 6 in the top. And I'm going to put the 4n minus 12 in the bottom. And then I have a square on that. I took care of the negative sign by flipping it. That's called the reciprocal piece. And then the second one, I'm not going to bother writing down right now. I would just bring that whole thing and rewrite it there. Now I got to deal with the squaring. Well, before I deal with the squaring, I would actually factor a GCF out on the top. So I think you guys will agree that's a 3 times an m plus 2. And in the bottom, I can factor out a 4. And that's an n minus 3. And this whole thing is still being squared. Once again, times, and I would still be bringing that thing down, and I'm not going to bother writing that yet. All right, so in the bottom here, on this side here, I got to square everything. So if I square the 3, I actually get 9. And if I square m plus 2, I get m plus 2 times a second m plus 2. And I'm writing it out for a reason, so you can see in a moment. In the bottom, I would square the 4, which is 16, and I would have 2 sets of n minus 3s versus writing n minus 3 being squared. Now we can go back to this other one here, and we can use some clues. If I'm taking a look at the top here, that's easier looking than the bottom for some reason. I don't know why. But we can just go and bust it up. But at the same time, you got your n's here in the top, right? Remember, you can cancel up and down. Well, m's and n's aren't going to cancel up and down. However, n's, which with the n's now in the bottom here, we can cancel diagonally in a minute. So if I take a look at it, I basically got a trinomial, so you want two sets of binomials. N squared is n and n. Since I got 3's down here, I know I'm probably going to get a 3 out of this somehow. The first sign was a minus on the n up here, right there. And the second one, the boss says it's got to be the opposite, so that's got to be a plus. And how do I get 3? There's only one way to get 3, guys, and it does subtract to 2, so it's 3 and 1. The bottom, by vice versa, same thing. The m's here are now going to cancel with the m's in the top here diagonally. So one of these m plus 2's is pretty much a given. I can pretty much say, hey, I know one of these is going to be an m plus 2. I got 2 of them in the top over there, so they got to cancel. Well, how do I get m squared plus 4? Well, it's m and m. I got a plus sign for the first one. The boss says it's got to be the same. And then how do you get 4 that adds up to 4? It's 2 and 2. So there we go. So everything is now factored. What cancels? M plus 2. M plus 2. N minus 3's cancel. And this n plus 1 is not going to cancel with the n minus 3, and 9 is made up of 3 and 3, and the 16 is 4 and 4, so I can't cancel that. So when I'm done, I've got 9 times n plus 1 all over 16 times n minus 3. So that would be my answer as far as that goes. Could I also write it by cleaning it up and putting it back together? Yes, I could. You could tell me it's 9n plus 9 on top if I distributed all over 16n minus 48. That's another possibility. Either one. If they asked you, though, a little more information, like where is it undefined, well, bottom line here is you can't go to the final answer here. I can't be just looking at this part here in the bottom. I got to look at the entire thing in the bottom, which turns out to be this part here is flipped here, because you can't divide by 0. The negative reciprocal flipped it. So this is the area that we're really looking at here. So where is it undefined? If I do it in blue, the n obviously cannot equal 3. Okay, in that problem. And what else do we got here? M can never equal negative 2. So if they ask you for the undefined part, that's where we're looking at. Okay, those are the restrictions in the denominator. All right. We're going to do more of these in class, but the bottom line is we can multiply tops times tops and all that good stuff. You got to factor, and we're going to get going. So see you in class tomorrow.